Hey everyone, welcome back to our channel Code with AKJ. Today is day 5 of solving LeetCode 75 challenge and today's problem is reverse vowels of a string. So if you are preparing for coding interviews or just want to level up your problem solving skills, you are in the right place. So the question says here, given a string S, reverse only all the vowels in the string and return it. The vowels are A, E, I, O, U and they can appear in both lowercase and uppercase more than once. So today we are going to solve an exciting problem called reverse vowels of a string. So in this problem we are given a string and our task is to reverse only the vowels in it. So we'll start with a brute force approach and gradually move on to the optimal solution. So let's dive right in. So given example here, input string S ice cream, where we can observe that the vowels are both in uppercase and lowercase. Here in this given string the vowels are I, E, capital A. So we need to reverse these vowels, giving out the output as A, C, E, C, R, E, L, M. So here you can see the explanation. The vowels in S, R, I, E, A, and on reversing the vowels, we'll get our string as this expected output. Same goes with example 2. Alright, so let's start with the brute force approach. In this method, we'll extract all the vowels from the string and we'll reverse them and then reinsert them into their original position. So here the step 1 would be to extract all the vowels from this given string and we store it in a separate container such as vector, and we'll reverse the vector containing the vowels and we traverse the string again, and every time we encounter a vowel we'll replace it with the next vowel from the vector we reversed all the vowels containing it. So this was a brute force approach. So let's try run that approach using these two examples. So first example is ice cream with I and A as uppercase letters. So here from this given string S, the vowels are I, E, and A. So we'll extract all these vowels and we'll store it in our vector and we'll reverse this vector. After reversing, we'll get A, E, and I. And now we'll again iterate over this string. We'll maintain a pointer I which starts from 0. Whenever we encounter a vowel in this given string, we'll replace this vowel with our vector's vowels using this pointer I. So let's try to try run this. So since we start from index 0, we found a vowel here. So we'll replace this capital I with capital A from this given vector. So the string is modified by replacing capital I to capital A. Again we'll move to the next index. Since it is not vowel, we'll again move it. So we found a vowel here. We'll replace it with our vector's next vowel. So our I contains at capital C. Since it is not vowel, we'll move to the next index. Since it is not vowel, we'll move to the next index. Since we found another vowel, we'll replace it with next vowel in our vector. So after replacing, we'll get our string as ice cream. So again our index moved to the next character. Here we again found a vowel. So we'll again replace this particular vowel with our vector's vowel, which is capital I. So finally we get our resultant string as ACECREIM. So this would be our resultant string after reversing all our vowels. So the time complexity of this approach would be O of n as we are iterating over the string, and space complexity would be O of n as we are using external data structure vector to store all our vowels. So here's the code for the brute force approach we have discussed by running this particular input. So we'll take a vector of vowels of type char, which will store all the characters of this particular string. Our first step here would be to extract all the vowels from this given string S by iterating over it, and we'll use our external function isVowel, which will help us identify that particular character is a vowel or not. Here we'll check both lowercase and uppercase. We'll store all those vowels in our vowels vector. And secondly, our second step would be to reverse all those collected vowels by using reverse function here. And finally, our third step would be to replace all those collected vowels in our original string. So we'll again iterate over this particular string S, and whenever we find a particular vowel, we'll try to replace that vowel with our collected vowel using our index IDX 0. And finally, after replacing all those vowels in our original string, we'll return that particular string. So let's try to run this code. It's working, so let's submit. As you can see, this problem got submitted successfully. So while this brute force approach works fine, but it takes two traversals of the string, which results in a time complexity of O of n, and here the space complexity is also O of n, as we are using an external data structure vector to store all the vowels. So let's try to optimize this further. So now let's talk about optimizing our solution. So instead of storing all the vowels in our vector and reversing them, we can use two pointers to reverse these vowels in place. So this will reduce the space complexity to O of 1, making the solution more efficient. So here's the plan for the optimal approach. We'll maintain two pointers here, I and j. I starts from the starting point of the string and j starts from the end of the string. So we'll move the left pointer forward and the right pointer backward until both point to vowels, and when they do, we'll swap them. So we'll repeat this process until the two pointers cross each other. So let's dry run with this. So here I starts from the starting point of the string s and j starts from the end point of the string j. So we'll move until or unless these two pointers point to a vowel. So here I points to a vowel but j does not point to a vowel. So we'll move j pointer one step backward. So j moves from here to here. So now let's again check whether these two pointers point to vowel or not. So since I character is a vowel and j character is a vowel, we'll stop here moving these two pointers, and now our next step would be to swap these two vowels. So after swapping, our string would look like this: A C E C R E I M. So after swapping, we'll move our pointers I and j one step forward and one step backward. So now I remains here and j remains here. Now let's again check whether these two characters are pointing to vowel or not. Since j is pointing to vowel, since I is not pointing to a vowel, we'll move I one step forward. And now since I and j are pointing to vowels, we'll stop and we'll swap these two vowels and we'll move pointers one step ahead and backward. So after swapping, our string will look like this: A C E C R E I M. I comes at here and j comes here. Since I and j are not pointing to vowels here, we'll move I one step forward and we'll move j one step backward. So here, as you can see, these two pointers crosses each other. So we'll stop the iteration here, and our final resultant string would be ACECREIM. So we'll return this particular string as an answer. So this is how our optimal approach works, and this is a small dry run of this particular string here. So let's move on to the code. So this is a code for the optimal approach we have discussed. Here I have taken two pointers, left and right. Left starts from index 0 and right starts from the end of the string. And we'll use a while loop where until or unless left is less than right. So we'll move left pointer until it points to a vowel using this particular while condition, and same goes with the right pointer. Until or unless it points to a vowel, we'll decrement the right pointer one step back, and when they both points to a vowel, we'll swap those vowels and move our left pointer and right pointer one step ahead and backward. So after doing all this operation and until or unless these two pointers crosses each other, we'll follow these steps, and if they cross each other, we'll stop our iteration, we'll come out of the while loop and we'll return our resultant string. So let's run this code. It's working, so let's submit. As you can see, this approach got accepted as well. So here's the time complexity would be O of n and the space complexity would be O of 1, making it more efficient while comparing to the brute force approach. So let's quickly analyze the time and space complexity of both approaches. So both the brute force and optimal solutions traverse the string linearly. Therefore, the time complexity is O of n, where n is the length of the string, and space complexity is O of 1, since we swap vowels in place without using extra space, whereas O of 1 due to the extra space used for storing vowels in brute force approach. So that's it for today's problem. We went from a simple brute force solution to an optimized in-place solution, reducing space complexity while maintaining linear time complexity. So if you found this video helpful, don't forget to hit the like button and subscribe for more such coding tutorials. Drop your thoughts or any questions you have in the comments below and I'll be happy to help. Thanks for watching and I'll see you in the next one.